When we think spring, we usually think, like gentle rain showers and flowers blooming.
Right.
But on Mars,
Yeah.
spring is a whole other
So I think
story.
this is a completely different beast.
So get ready, because today we're doing a deep dive into a Martian spring that is anything but gentle.
That's right. And to do that, we're going to be looking at some really cool research from NASA's Jet Propulsion Laboratory.
Okay.
Their latest article, Mars Awakens for the New Year, Explosive Springs and Wandering Dunes.
Catchy title.
Yeah, paints a pretty dramatic picture
It does.
of what's happening on Mars right now.
So first things first, Mars actually just celebrated its new year on November 12th, 2024.
That's right.
And guess what?
Right.
It's springtime
Yeah.
in the planet's northern hemisphere.
Yes. But keep in mind,
Okay.
a Martian year is 687 Earth days long.
Wow.
So that means seasons on Mars last much longer than what we're used to here on Earth.
Okay, so no quick changeover from winter to spring on Mars.
Oh.
But here's where things get really interesting. Unlike Earth with, all of our lovely liquid water,
Yeah.
Mars has a super thin atmosphere.
Right. And that thin atmosphere means that liquid water is pretty scarce.
Okay.
So instead of ice melting like it does here on Earth,
Right.
it goes straight from solid to gas.
Uh-huh.
It's a process called sublimation.
Sublimation, huh?
Yeah.
I remember that from science class, but I honestly never thought about it happening on a planetary scale.
It's one of the key reasons why Martian spring is so dramatic.
Okay.
Think about it. No gentle trickling streams or melting snowdrifts.
Yeah.
Instead, the ice just vaporizes. And that process can be pretty violent.
So instead of a gentle thaw, we're talking explosions.
Yeah.
That's kind of intense for springtime.
It is. Imagine cracks splitting across the Martian surface, explosive bursts of gas as the ice vaporizes, and this symphony of Martian booms replacing the sounds of birds chirping.
That's quite a contrast to the peaceful image of spring that we have here on Earth.
Definitely.
Now, speaking of dramatic visuals, I was looking at some of the images from NASA's Mars Reconnaissance Orbiter, or MRO.
MRO.
And wow, they're incredible.
It's an amazing piece of technology, isn't it?
It is.
MRO has been orbiting Mars for almost 20 years,
Wow.
giving us this front row seat to these seasonal changes.
It's amazing that we can see these events happening millions of miles away.
I know, it's incredible.
One photo actually shows a huge chunk of dry ice, like 66 feet wide,
Wow.
caught in midair as it breaks off a cliff.
Oh, wow.
It's like a Martian avalanche.
Yeah, it really highlights how dynamic the Martian surface is, even during what we might consider, a quote-unquote quiet season.
Yeah.
And those explosive events aren't limited to just falling ice.
Okay.
There are these incredible gas geysers that erupt as the surface warms up.
I was reading about those geysers.
Yeah.
Sounds like something straight out of a science fiction movie.
Picture this: sunlight penetrates the dry ice, warming the lower layers and turning them into gas.
Okay.
That gas gets trapped beneath the surface, the pressure builds, and boom, a geyser erupts. These eruptions launch these dark fans of sand and dust across the landscape.
So it's not just the ice exploding,
Uh-huh.
but the ground itself is erupting too.
It is. It's wild.
That's wild. And I read that scientists are expecting even larger geysers in the southern hemisphere when spring hits there in December 2025.
That's right. The southern hemisphere has much larger areas that are covered in dry ice.
Oh, wow.
So the potential for those eruptions is even greater.
That's definitely something to look forward to. But back to the north. After those geyser shows wrap up,
Yeah.
something even stranger happens. Those mysterious spider leg patterns.
Ah, yes. Those are fascinating.
They are.
Those spidey legs are actually networks of cracks
Okay.
that radiate outward from where the geysers were.
Uh-huh.
And what's really interesting is that scientists have actually managed to recreate this process in labs here on Earth.
Wow.
They've shown how that escaping gas carves these spider-like channels into the surface.
So these aren't just some random patterns.
No.
They're direct evidence of the power of those gas eruptions.
Right.
It's amazing to think that we can understand these alien processes by studying them here on Earth.
Yeah, it really is.
Now let's zoom out a bit and talk about those massive swirls at the North Pole.
Okay.
They look like giant swirling troughs carved into the ice cap.
You're absolutely right.
Yeah.
Those troughs are actually called spiral troughs, and they're carved by wind over incredibly long periods of time.
Just how big are we talking?
Some of these troughs are incredibly long. We're talking the length of California.
Wow.
Imagine that giant canyons carved into the ice by the relentless Martian winds.
Okay, so we've got frost avalanches, gas geysers, and swirling ice canyons.
Yeah.
Is there anything else Martian spring throws at us?
Oh, there's more. Just like on Earth, Martian dunes migrate with the wind.
Okay.
But here's the twist. During the Martian winter, carbon dioxide frost freezes those dunes in place.
Wait, so the dunes are literally frozen in place?
Exactly. It's like hitting the pause button on their movement.
Wow.
The CO2 frost actually bonds to the dune particles, preventing them from shifting. But then spring arrives, the frost thaws, and the dunes resume their slow dance across the landscape.
It's amazing how these seemingly small changes in temperature can trigger such dramatic transformations on the Martian surface.
It really is.
It makes you wonder what it would actually be like to experience a Martian spring firsthand.
That's a great question, and one we'll explore in the next part of our deep dive.
I'm excited to keep going.
Me too.
We're going to take a hypothetical trip to Mars and imagine what it would be like to stand on the surface, feel that Martian air,
Right.
and witness these incredible events unfolding before our very eyes.
Let's do it.
Okay, so buckle up, everybody, because this Martian spring adventure is just getting started.
That's right.
All right, so we've covered, like, the science behind Martian spring, but now I'm really curious what it would actually be like to experience it firsthand.
Yeah.
Can we put on our imaginary spacesuits?
Let's do it.
Take a trip to the red planet?
Okay, let's give it a try. Imagine you're standing on this Martian cliff face. The air is thin, incredibly cold, even though it's technically spring. You're looking out over this vast landscape of reddish-brown dust and rock.
It's funny because on Earth, spring is all about, vibrant colors and sounds.
Yeah.
But Mars, even in spring, seems like it would be pretty quiet and monochromatic, wouldn't it?
The silence would be profound, yes.
Yeah.
But then you hear this faint cracking sound in the distance.
Okay.
It gets louder, closer, and suddenly, boom, a massive chunk of dry ice breaks off a nearby cliff and crashes to the ground, sending up this plume of dust.
That's incredible.
Yeah.
You'd probably feel the ground vibrate beneath your feet.
Definitely.
So much for a quiet spring day.
Exactly. And then as the dust settles, you notice something strange happening near the base of the cliff.
Okay.
The ground seems to be breathing.
Breathing. Okay, now that's a bit creepy. What's going on there?
Remember those Martian geysers we talked about?
Yeah.
Sunlight is penetrating the dry ice, warming the lower layers and turning them into gas. That pressure builds, and suddenly a jet of gas erupts, carrying sand and dust high into the air.
So those plumes of dust we see in the photos,
Yeah.
we'd actually see them shooting up from the surface.
You would.
Would we feel the force of the eruption too, or is it more of a visual thing?
It depends on how close you are. But those geysers pack a punch. You might feel a gust of wind, or even get dusted with some Martian sand.
It's amazing to think that for centuries, people looked at Mars as this unchanging, almost dead world.
I know.
But now we know it's a planet with active seasons, weather patterns, and even these, dramatic explosive events.
It really challenges our assumptions about what a planet can be, doesn't it?
It really does.
Yeah.
And speaking of dramatic events, we can't forget about those powerful winds that carve those giant swirling canyons at the North Pole.
Right.
What would it be like to experience those firsthand?
Oh, I bet that would be wild. Imagine standing on the edge of one of those spiral troughs bundled up in your spacesuit and feeling the full force of a Martian windstorm.
I'm guessing it wouldn't be a gentle breeze.
Not at all. These winds can reach speeds of up to 60 miles per hour, whipping up dust devils and creating this hazy, swirling atmosphere.
So not exactly a relaxing stroll in the park.
Hmm.
I imagine the sound will be pretty intense too, almost like a roar as the wind whips through those canyons.
Yeah.
And visibility would be pretty low with all that dust flying around.
You'd be right. It would be a truly immersive experience, both exhilarating and a little bit daunting.
Yeah.
You'd be witnessing the raw power of nature shaping a planet right before your eyes.
It's funny because when we think of spring,
Yeah.
we usually picture, gentle showers and blooming flowers.
Yeah.
But on Mars, spring is this harsh, almost violent display of nature's power.
It is.
I guess it really puts things into perspective, doesn't it?
It does.
Our definition of spring is pretty Earth-centric.
It is. And remember, we've primarily been focusing on the northern hemisphere spring.
Right?
The southern hemisphere likely holds its own unique spring spectacles waiting to be discovered.
Now, that's a great point. We mentioned earlier that the southern hemisphere has larger areas covered in dry ice.
Yes.
So would that mean even more dramatic events when spring arrives there?
It's definitely possible. We might see even larger geysers, different types of frost formations or wind patterns that create entirely new surface features.
Okay, so bigger geysers, potentially even stronger winds.
Mm-hmm.
It sounds like the southern hemisphere's spring could be even wilder than what we've been discussing.
Yeah.
I'm starting to think spring break on Mars might not be such a great idea.
Probably not the best vacation spot, no.
No.
But for scientists, it's an incredible opportunity to learn more about how different regions of Mars respond to seasonal changes.
That's true. Each new observation brings us closer to understanding this dynamic and fascinating planet. But I have to ask, with all this focus on the dramatic and the explosive, are we overlooking anything? Could there be something going on during Martian spring that's more subtle, less obvious?
You're asking the right questions. We tend to be drawn to the spectacular, but sometimes the most profound changes happen on a much smaller scale. And that brings us to one of the biggest mysteries of all the possibility of microbial life on Mars.
Now, that's a topic that always sparks debate. What makes you think that life could be lurking beneath the Martian surface? And how would it be affected by the Martian spring?
We know that there are organisms here on Earth called extremophiles that can survive in incredibly harsh environments.
Okay.
Extreme temperatures, high salinity, intense radiation, the kind of environments that in many ways resemble parts of Mars.
So you're saying there could be tiny organisms on Mars that are perfectly adapted to the planet's harsh conditions.
Yeah.
They might even be thriving in those seemingly desolate landscapes.
Exactly. And the Martian spring, with its subtle shifts in temperature and pressure, might be the trigger for these organisms to become active.
Okay.
Imagine a layer of permafrost deep beneath the surface.
Yeah.
As spring arrives, it begins to thaw, even if just slightly.
Creating pockets of liquid water, maybe?
Possibly.
The kind of environment where those extremophiles could flourish?
Precisely. And with that water comes the potential for chemical reactions, the release of nutrients, and this burst of biological activity that might be completely invisible to us from orbit.
It's mind-blowing to think that these tiny hidden worlds could be waking up every Martian spring, completely oblivious to the dramatic events happening above. It makes you realize how much we still don't know about this planet.
It's a humbling thought, and it highlights the importance of looking beyond the obvious, of considering the unseen when searching for signs of life beyond Earth.
So how do we even begin to study these potential microbial communities? We can't exactly dig up the entire Martian surface, can we?
That's where future missions come in.
Okay.
Rovers equipped with advanced drilling capabilities and sensitive instruments could analyze samples from deep below the surface, searching for biosignatures, telltale signs of past or present life.
I can picture it now. A rover carefully extracting a core sample from the Martian permafrost, and as scientists analyze it back on Earth, they detect those faint chemical traces that hint at a hidden ecosystem. It would be a revolutionary discovery.
It would rewrite our understanding of life in the universe, and it would underscore the incredible resilience and adaptability of life itself.
Welcome back to our Martian Spring Deep Dive. We've journeyed from explosive geysers and avalanches to the mind-boggling possibility of microscopic life waking up beneath the Martian surface.
It's been quite a ride.
It has. And it really highlights how much we've learned about Mars, in just the past few decades.
It's incredible, isn't it?
It is. It's funny to think that for a long time we imagined Mars as this static, red, dusty planet.
Right.
But now we know it's a dynamic world with active seasons, wild weather, and maybe even life we can't see with the naked eye.
It really changes our whole perspective on the red planet.
It does. So, okay, we've talked about the possibility of these Martian extremophiles.
Yeah.
But how would they even survive in such a harsh environment? I mean, we're talking about a planet with a thin atmosphere, frigid temperatures, intense radiation.
Right, but remember, extremophiles on Earth thrive in conditions that would be lethal to most other life forms.
Right.
They've evolved these unique adaptations to cope with extreme temperatures, lack of water, and even high levels of radiation.
So these Martian microbes, if they exist, would have to be some seriously tough little critters.
They would.
But how would they get the energy they need to survive?
Photosynthesis seems kind of out of the question given the lack of sunlight reaching the subsurface.
Good point.
Yeah.
It's unlikely they'd rely on photosynthesis like plants do here. Instead, they might get their energy from chemical reactions in the rocks and soil, a process called chemosynthesis.
Chemosynthesis.
Yeah.
So they're basically eating rocks.
In a way, yes.
Yeah.
They'd be extracting energy from the chemical bonds in minerals rather than from sunlight.
That's incredible. It really expands our understanding of what life could look like, not just on Mars, but throughout the universe.
Absolutely. It challenges our Earth-centric view of life and opens up this whole realm of possibilities.
Okay, but let's get back to Martian spring. We talked about how the thawing permafrost might create these pockets of liquid water.
The kind of environment where these extremophiles could thrive. But how long would those pockets of water last?
That's a key question, and it really depends on the depth of the permafrost and the intensity of the Martian spring.
Okay.
These pockets of water might exist for only a brief period, creating a sort of pulse of life.
Interesting.
As the microbes become active, reproduce, and then go dormant again as the water freezes.
So it's like a cycle of life and dormancy, timed to the rhythm of the Martian seasons.
It is. It's amazing to think about.
It is. All this talk about microbial life is fascinating.
Yeah.
But it also raises a big question. How do we actually find evidence of these tiny organisms? We can't exactly send a rover down with a microscope and start looking around.
You're right. It's a huge challenge. But future missions are being designed with this very goal in mind.
Okay.
Rovers equipped with drills and these very sensitive instruments could analyze samples from deep below the surface, searching for those telltale signs of life.
We're talking about those biosignatures you mentioned earlier, right?
Exactly.
What exactly would scientists be looking for in those samples?
They'd be looking for specific molecules and isotopes that are indicative of biological processes. Things like complex organic molecules, certain ratios of carbon isotopes, or even fossilized microbes themselves.
Wow.
It's really incredible.
It's like piecing together a puzzle, isn't it?
It is.
Each clue, each biosignature, bringing us closer to answering that question of whether we're alone in the universe.
A question that has haunted humanity for millennia.
It has. What I have to say, this deep dive has completely changed my perspective on Martian spring.
I'm glad to hear that.
It's not just about, dramatic geysers and swirling ice canyons. It's about the potential for life hidden beneath the surface, pulsing to the rhythm of the Martian seasons.
And that's what makes it so fascinating.
It really is. It makes you realize there's so much more to learn about this planet and about our place in the cosmos.
Exactly. It's a reminder to never stop exploring, to never stop asking questions, and to always be open to the unexpected.
Couldn't have said it better myself. Thanks for joining us for this journey to Mars. And until next time, keep looking up.
Keep wondering and keep exploring.